Finishing up section 4. One more rule. The rule for raising a quotient to a power is similar to raising powers of powers. Remember, when you have a power, this should say products. But when you have a product, a times b to the nth power, then we can send in that exponent. We wind up with a to the n times b to the n. We learned that one in the last section. This one works very similarly. So before I talk about this, let's do this first one right here. When I have something squared, what does something squared mean? It's times itself, yeah. So I'm going to rewrite this, just like I've been doing all along, as 4 over x to the third times itself. 4 over x to the third. And now we have two fractions that we're multiplying together. You guys see that? How do I multiply fractions? Just multiply across, yeah. So in the top, the numerators, we have 4 times 4, which becomes, yeah, we know it's 16, but I don't want to write 16. I want to write 4 squared. Divided by multiply across x to the, when we multiply like bases, we do what with our exponents? Add them. So we get x to the 6th. So 4 squared over x to the 6th. Well, take a look back at the original problem, and what happened with this exponent compared to the numerator and denominator? Yeah, it went to both, yeah. So just like on this one here with that n outside, and we send it in to both terms, here we're going to take that 2 and send it in also to both terms, but it's going to the numerator and denominator this time. We had 4 to the first to the second power, so it became 4 squared. We had x to the third to the second power, so it became x to the 2 times 3, or x to the 6th. And that's the property right here. To raise a quotient is a division problem, to a power, raise the numerator and the denominator to the power and simplify. And that's exactly what we did. You're sending that exponent outside to the top and to the bottom. And then you can avoid writing this. So let's take a look at this one. What should we do? Yeah, do the power to the power in the top and the bottom. So in the top, we get a to the what? 3/4 times 4 is 3. Divided by a to the, I really can't hear the whispers. 20th, thank you. Okay, are we done? No, we're not done, because we still have like bases that we can simplify. So to simplify this one, what do we need to do? Subtract the exponents. Yeah, we're dividing like bases there, and when you divide like bases, you subtract the exponents. So when we do that, we get a to the what? Negative 17. 3 minus 20 is negative 17. And is that our answer? No, still not done, because what's wrong here? Negative exponent, we can't have that in our answer. So what am I going to write? 1 over a to the 17th. And you're done. So there's actually quite a bit more to do there, but we got to the answer. Yeah. So on this first one right here, normally we would just go 4 squared, but 4 squared is 16, so our answer here needs to be 16 over x to the 6th. Thanks. Forgot about doing that. We want to multiply out those exponents for our numbers. Okay, maybe that third one is easier. X squared over y, that's all to the third power. What do we do? Okay, that's right. We're going to send in the exponent to the top and to the bottom. And what do we get? To y to the third. And then can I simplify that? If you're saying no, you are correct, why can I not simplify that? Because x and y are different. Yeah, those are not like bases. So that's as far as you can go there. Over here, those were like bases, so that's why I was able to simplify. But in this case, they're not like bases, so I can't do anything with it. I got to stop. All right, how about this last one? Send in the exponent. So when I do that, what do I get for my numerator? 5 to the negative first, that's right, over x to the negative first. Is that a good answer? No. So what do I need to do? Yeah, so we draw a fraction bar, and then the 5 to the negative first power goes where? In the bottom, and I'm just going to write 5 to the first, which is just 5. What about that x to the negative first? Is that already good because it's in the denominator? No. It has to go up. It's in the wrong spot as well. So it has to go up here, and I wind up with x in the numerator. X over 5 is my answer. All right, we have 4 problems left to do here. It says, remember, a negative exponent means take the reciprocal. So if the exponent outside is negative, what you could do is flip the thing inside completely. What was on the bottom is now on the top. What was on the top is now on the bottom. And then the negative exponent is gone. The exponent's still there, though. But the negative part of that exponent is gone. Let me go back to this problem that we just did. With that negative exponent out here, what I could have done was said, okay, I can reciprocal this, flip it, and I wind up with a positive exponent here now. So if I do that, I get x over 5 to the first power. Well, anything to the first power is what I started with in the first place. So I get the x over 5 there. Little different way of thinking about that problem, but you still get to the same answer in the end. Sometimes it's easier to do it that way. So we're going to take a look at these 4 problems and deal with the negative exponent first, and then work with positive exponents. So, what will I have for that first one? Right, the negative nth power here tells me take the reciprocal of this. That becomes b over a, but that's still to the positive n power. And then what happens? Send in the n. And we get? That's right. There's your answer. Those aren't like bases, so I can't go any farther than that. So I'm done. And how about that second one? What should we do? What? Flip it. All right. That gives me what? I flipped it. So now it's just to the 2. Now what? Send it in and we get x to the 4th over 16. Can't do anything else, so I'm done. All right, go ahead and give those 2 a shot. They're obviously a little bit more complicated, so be careful. But they're done pretty much the same way. So what happens first? Reciprocal, and we get? Now it's to the 3rd power. Okay. Now what? Okay, and we get? Good. 2 to the third x to the 6 times 3 is 18. Remember, when you are raising powers to powers, you multiply the exponents. So 2 to the third x to the 18th. Now, is that my answer? No, because I got to take care of that 2 to the third thing. So I still have y to the 12th over 8 x to the 18th power. That's my answer. And the last one, what do we do? A reciprocal, and we have 5b over a to the positive second power now. And then send in the 2, but the 2 goes to both of those in the top and that thing in the bottom. So that's 5 squared b squared over a squared. 25 b squared over a squared. There's your answer. So, a couple of different things happen in this problem. One was this 3, the outer exponent, did go to the top and the bottom, but with more stuff going on in the denominator or more stuff going on in the numerator, that exponent actually goes to every single thing. Goes to every single thing. So be careful about that.